Okay, we're on Pn junctions. So let's apply an electric field across the Pn junction. So what we're going to do is connect the battery up, P to the positive and N to the negative of the terminal of the battery. Now you're applying a voltage there, and if the voltage of the battery exceeds the junction voltage, a current will readily flow. If it doesn't exceed the junction voltage, a current can flow across the depletion layer. And that is all this section is really going to say. Here is one way to interpret that. So if we close the switch, we get an electric field immediately. Okay, when it's like this with the P connected to the positive and the N connected to the negative, we say the junction or the diode is in forward bias. All right, as a result now the electrons will be repelled from the negative, from the right side, and the holes will be repelled from the positive. So they'll be pushed towards each other. And then what happens is they're pushed into the depletion layer, and one way of explaining this is the depletion layer decreases in size. As a result, then the current can flow easily. Now that's only if the applied voltage is greater than the junction voltage. Okay. So what we have there is about 0.6 volts for the junction voltage. So if the applied voltage is greater than that, then a current can flow. Okay, if you apply a higher voltage, the electrons just flow faster, so the current will flow more as well. Okay, we have a diode represented by this symbol. So you need to know that that's the symbol for a diode, where the left side of that arrow is the p-type and the vertical line is the n-type side. Okay, what if we change the battery around though? So in this case, we have the n-type connected to the positive, the p-type connected to the negative, and if we close the switch, the electrons will be attracted to the positive terminal, the holes will be attracted to the negative terminal. This thing now is called a reverse bias diode, and what ends up happening is the depletion layer increases in size, so as a result no current will flow. So the depletion layer increases in size, and as a result this behaves as an insulator, the entire thing behaves as an insulator, and no current flows. So if the diode is connected one way, a current can flow. If it's connected the other way, no current can flow. So the diode behaves similar to a one-way valve. So it will allow current to go one way, not the other. All right, so this is what you need to remember. If you connect the diode in reverse bias, the depletion layer increases, so it becomes difficult for charged particles to travel through the diode. All right, a bit of information on the semiconductor diode then. It's just a Pn junction. In reverse bias, it doesn't connect or doesn't conduct. In forward bias, it does conduct an electric current. And then you should always have a protective resistor, roughly 330 ohms in series, because diodes only take a small current, and the resistor will limit the current flowing in the circuit.